G'day and welcome back to Stiffy's Workshop. Today I've basically had my intake manifold off, which connects the carburetor to the main part of the engine. Have a big crack in it, so you can see there I've got a massive crack which was letting unmetered air in, and it had previously a JB Weld repair, however that has failed, and on removing it I have snapped off one of the studs inside the engine because it was cross-threaded. Now it's supposed to look like this with the head still intact, whereas the head on my other bolt had broken off, leaving a bit of thread exposed. Now I've successfully extracted that portion, however I'm left with a cylinder head which has some bad threads, and I can't just put another screw in there because it won't work. It gets to 2-3 threads in, like I see there, and I can't get any further. So what you're going to need to fix this one up is a metric tap and die set, or specifically just the one you need. Now in this case the bolt's about 6mm in diameter and the thread pitch looks to be about 1mm. So I'll start by checking my M6x1 taps, just lining them up there, roughing it in, making sure that we can confirm that's the correct size before we go any further. So trying to line up two things. One is the thread pitch, so how close together the threads are. The other one is the diameter. We want to make sure we get both of those correct. So in this case that lines up nicely in terms of the diameter, and the threads sit in nicely. So that's telling me it's most likely an M6x1, and being a Japanese motorcycle it'll be a metric thread, so I don't need to worry about it being an imperial thread. If I go the size down to the M6x0.75, we can see that doesn't sit in nicely, whereas the 6x1 thread sits in nicely to the bolt I've got. Now when you're tapping it's really important to have enough space to be able to move your tool, and this tool here fits in just nicely. If I was having trouble tapping it, if it was very challenging to get the tap started, I would have to sort of drop the engine and just give myself some more space, some more working space. But in this instance this works nicely. I have just enough space. And it's really important to sort of tweak the tap over, especially when you're first starting, or especially when you're in a soft metal like aluminium, because in this instance we're really relying on the tool to hold the work in, or me holding it straight. So if you're pushing really hard on one side, the tool can sort of push across and it won't go in straight, which will damage things. But now we've got a couple of turns on it, we can quite confident it's going in straight. If you're not sure, just stop and make sure things are working nicely before you go too far with it. With this one I'm making good progress, so we have lost a fair bit of material in the cylinder head, so it's probably making it easier to cut than it would be otherwise. I try doing the other side a bit later, because it's always good practice if you're doing one bolt to then retap the other one as well, because either they've both been over-torqued and the threads have been compromised, or alternatively the other side may well, you might end up having to hold more torque than the side that I'm tapping here that's damaged. So you want to make sure it's in as good a condition as possible, just to minimise pain down the track next time you're playing with it. And because it's not taking a lot of pressure to go in, I'm mainly just going in the forward direction. If I was feeling a lot of resistance, I would go forwards and then back and extract all the filings. So I'll be making little chips of aluminium as I go, and you don't want to get too greedy because you want to make sure the bolts can go all the way through. If you have a situation where you have a through hole, so a hole where you can see the other side, you can go a lot harder because you can get chips out from both sides. But whereas this is a captive hole, so it becomes difficult to get the chips out if you go too far, and if you push too far you can damage the tool and have it snap off, and taps are very difficult to get out of holes, so you really don't want to get greedy in the case of a material like this. And as I mentioned before, I'm not using cutting fluid, so you can see how much material I'm moving. However, it's always a good idea to use cutting fluid. So you can see there, I've got some little chippies out of it, sort of being held in the flutes of the tool. Those sections running up sideways that don't do any of the cutting. And now we'll come back and go a bit further. So I've cleaned the tool out, so it's a good idea to do that periodically. I'm not in a massive rush. What I'm trying to do is do the repair in a way that's going to be a confident fix sort of thing. So you can see there, I'm about halfway down with the tool, so that's a great start so far. I'm just going to run it the rest of the way. And again, just making sure you're applying pressure evenly on both sides is a really good idea. If you're pushing really hard on one side, you can damage the tool, and that's obviously not going to be good. And secondly, you can push the hole off center. So you really just want to be turning. You don't want to be pushing any sort of unbalanced torque on there. That's tapping really nicely now, which tells me we're into some good threads. So it was probably only some of the threads that were damaged. And that's about as far as we want to go. Just kind of where it sort of stops. You don't need to get so many threads in there. And one trick you can use if you do get little bits of filings in the bottom that don't come out, you can either turn the bike upside down, or you can get a straw on the end of a vacuum cleaner and just pull it, like suck it up with a straw, the little chips. However, I'm just going to put a bolt in with some Loctite, just low strength Loctite. Great, that's all come out. You can see I've got a lot more rubbish on the tap. Now to finish up, it's always a good idea, come over with the bolt you're going to be screwing into it, make sure the bolt's not stretched or wrecked. And if it goes in like this, nice and easy, it's not rattling around all loosey-goosey, that means you've got a usable thread, you don't need to put a helicoil into it. Winner, winner.